So this is topic D1 review for IB Physics on gravitational fields. Let's start with main problem types that we'll see. So first are plugging real numbers into equations, and next ratios within equations. So they won't give you real numbers and you'll kind of explore how changing one variable affects others. Next are deriving and showing equations. A lot of the times these equations are already in the formula booklet or already given to you, but they want to see your process. And lastly are interpreting graphs, which I think is one of the harder parts of this topic. Let's start by looking at some key terms. I'm not going to explain in depth what all of them are, but you should be able to recognize if a question's asking for them, because obviously the question won't just give you all the letters that you're going to use. So first, gravitational field strength or gravitational acceleration both indicate g in meters per second squared. As we know, this is 9.8 on Earth, but once you leave Earth, that changes. Vg is gravitational potential, which is in joules per kg or meters squared per second squared, and it has a formal definition of like work done per unit mass to move a point mass from infinity to a specific point. But I think it's easier to understand if you just think about it as the potential energy that an object has due to gravity. So that's why it's gravitational potential. Next, capital G is universal gravitational constant, which applies to any planet, any sun in any solar system or galaxy. That's why it's universal. And R is the distance between the centers of two objects, not their surfaces, their centers, which really matters once you have an object as big as like the Earth. And next, know what escape velocity and orbital velocity are. So orbital velocity is the velocity that an object must stay at to stay in orbit without falling towards the planet, and escape velocity is the velocity that it must reach to entirely escape orbit. And lastly, know Kepler's 3 laws. They're not that hard to understand, but many questions might ask you about them. So let's start with deriving the equation for orbital velocity, which I've seen a lot of questions ask for. So the first thing that you do when you see deriving the equation basically means that you have to find two equations that are equal to each other and try to isolate a variable, which in this case would be orbital velocity. So orbital velocity would be the velocity that an object is traveling in orbit. So let's think about this. If there's a planet and an object is in orbit around it, what forces are acting on this object? Well, the only force acting on it is gravity at this point. So as Newton's law of gravitation says, force of gravity is equal to capital G times mass over r squared. So that's your first equation. But if you think about it, gravity is also a centripetal force because the object, which is in circular motion, there's a force pulling it towards the center. And so this is also equal to the equation for centripetal force, which is mass times velocity squared over r. And there you have the velocity variable that you're trying to isolate. So to derive the equation, you just have to isolate v using cross multiplication. And that's how you derive orbital velocity, which this equation is in the formula booklet, but they still want to see how you get there. Another equation that they often ask you to show is Kepler's third law, which states that t, which is orbital period squared, is directly proportional to orbital radius r cubed. So to show how this law works, you have to show that a constant times r cubed is equal to t squared. So we have to equate two equations that have t and r in them. So first we can actually use the equation for orbital velocity, which is v equals square root of gm over r, which we just derived. So that already has r in it. And now we have to find a way to equate it to an equation with t in it. If we think about it, orbital period is time, right? And velocity is displacement over time. So we can already have time at the bottom. And being the time it takes for an object to make one orbit, this means that the distance is the distance that an object makes in one orbit. And since orbital radius r times 2 would be diameter, this times pi would be the circumference or distance of this orbit. So now we have two equations that are equal to each other, and we can try to set t squared to be equal to a constant times or cubed. And through this equation, we can prove Kepler's third law to be true, because 4 pi squared over g times m will be a constant, as long as it is for the same star or object, because it is mass. Another equation that they might ask you to derive is the equation for the total energy of an object in orbit. So as we know from the law of conservation of energy, E total is equal to EK plus EP. And EK, as we know from previous lessons, is equal to mv squared over 2. And EP, from this unit, this equation is in the formula booklet, but it has a new equation. But from what we just derived, remember, V is equal to square root of gm over r. So this equation is really important. It keeps coming up. We also know that gm over r is equal to v squared. And you might recognize that this part is the same as this part. So now we also know that EP is also equal to negative v squared times m. It's basically a part of the kinetic energy equation. So now it's easy to add them up to get the total energy. So this equation can be used to find the total energy that an object has while it's in orbit. But it's important to remember that this is for the energy that it possesses while in orbit and not the amount of energy needed to get it to orbit in the first place. Okay, let's now look at some example questions. So this is one of the questions that I talked about where they ask you to compare ratios. So it says that stars A and B, they have the same mass, but the radius of A is 9 times larger than the radius of B, and find ratio of gravitational field strength, which is G. So we can start with G A is equal to G times its mass. They have the same mass. And the R is 9 times that of B. So to make things easier, I'm just going to have R be the radius of B. So this would be 9R squared. And G of B would be equal to G times M over R squared. And if we find the ratio of these, we'll just find that the ratio is 1 over 81. Another type of question might ask you to estimate the fraction of distance where the field strength is 0. So first, Earth and the moon. So since it asks for a fraction, we can just set the total distance to 1. And it's trying to find the distance to a point where gravitational field strength is 0. So if it is this point, then we can estimate this as D. So at a point where G is equal to 0, this means that the G of Earth minus the G of the moon equal to 0, which also means that they will be equal to each other. Now, using the equation for gravitational field strength, know that the G of Earth is G times 81 times the mass of the moon divided by D squared, which is the distance to this point, and this is equal to G of the moon, and this one will be 1 minus D squared. So if we cancel out the GMs, we get that D squared is equal to 81 times 1 minus D squared. And by simplifying this equation and solving it with your calculator, we can find D, which will be a fraction. So finally, we're going to look at graphing, which in this topic is based on 4 main graphs, based on the 4 main equations. So FG, EP, VG, and G. And I've written out the equations of these y variables here, which is a good way of understanding how the graph works, because you can see what the slope of the graph actually is. And because all of them divide by r, that's why the graphs are curved. And most of the questions relating to the graphs it will be between these vertical graphs, so FG and EP and G and VG. So to go between these, if you go from FG to EP, you will integrate, and if you go from G to VG, you will also be integrating. And that goes into calculus, which I'm not going to talk about, but integrating basically means that you have to find the area under the slope, and you're multiplying, which I'll talk about next with an example. Differentiating basically just undoes integrating, so instead of going from FG to EP, you're now going from EP to FG. So when you integrated, you found the area, and by finding the area, you basically multiplied the x and y variables. But when you differentiate, you have to find the slope, because you're dividing y over x, and you find the slope by drawing a tangent. And the greatest y values, remember, are when the slope is the steepest and not when the value is necessarily highest. So for example, if you're asked to find VG using a G and R graph, first you have to find out if you're multiplying or dividing, so if you're integrating or differentiating. So let's try dividing first, right? So you know that G is equal to capital G times M over R squared. So if you divide this by R, you're basically multiplying by 1 over R, right? You will get G times M over R cubed, which isn't anything. It's not equal to VG. So you know that for this one, you're actually multiplying, so you're integrating. And you can kind of see that by multiplying by R, which will give you GM over R. If you know your equations, that's the equation for VG, but you just have to remember to add a negative sign. So you just basically have to try to multiply x and y or divide y by x to decide which method you have to use. And now that I know I have to integrate it, I integrate by finding the area under the slope, which I'm not going to do with this example because I don't have real numbers to count with, but you usually do this by counting the boxes and then using the units label on the graph to estimate the area. So this question asks for integrating, but if you had ended up dividing, then you would basically draw a tangent, like something like that. So you would have to find the slope, the instantaneous slope of this point, and you do that by comparing its change in y to its change in x. And this slope, well, on a G and R graph, the slope wouldn't mean anything. But if today you had a VG versus R graph, the slope would be the gravitational field strength G, because that's the relationship that these two graphs have. And that's it for this video. I hope it helped, and good luck, everyone, with the test.